So let's talk about transformers. A transformer is a type of neural network architecture designed to work with sequences. A sequence simply means a sentence, basically like words in order, audio, video frames, lines of code, etc. So earlier we had neural networks which were specialized. For example, the ANN was for tabular data, the CNN was for images, the RNN slash LSTM was like for text and time sequences. What transformer did is it's like long sequences plus the context understanding. So when you take an example, boy crossed the road, so it understands the entire sentence. It takes the entire sentence as a vector input. So the core idea behind this was a transformer converts one sequence into another sequence. So for example, if we give input as English sentence and we want output as Hindi sentence, we give input as questions, we get output as answers, we give input as articles, we get output as summary or whatever we want. So instead of predicting just one value, it produces another structured sequence, and that is why it is called transformers. It transforms the information. Now, why is it important or why is it revolutionary? Older models read the text word by word. Transformer reads all words at once. So imagine reading something like, let's take an example. The animal did not cross the street because it was tired. So we instantly understand that it is equals to animal. Now transformer learn this relationship mathematically. Now, transformer learn this relationship mathematically. Let's talk about high level architecture. So it has three parts: encoder, self-attention, and decoder. So input is there, then it gets to encoder, then attention, then decoder, and then to output. So let's understand each one simply. Encoder. The encoder reads the input sentences and builds the meaning in it. For example, the input sentence is, my name is Ranveer. The encoder does not just store words, it learns the relationship, the grammar, the importance, and the context. So, name relates strongly to Ranveer. Each word becomes a vector. Vector is basically a number representing the meaning. Then there is self attention. Self attention is basically like the brain. So this is the most important part. Every word asks, which other word should I pay attention to? For example, the vet took, the animal didn't cross the road because it was tired. When we are processing it, the model checks the animal, cross, and tired, the three words, right? Now it assigns attention scores to each of the word. So mathematically, it will get assigned to animal and then it will have high attention. Then once it gets assigned to tired, it will have medium attention, and it gets assigned to cross and it will have lower attention. So now model understands the reference. Decoder is basically a generation phase. So after understanding the input, the decoder generates the output. For example of translation, if the input is my name is Ranveer, the output will be Mera naam Ranveer hai. Decoder predicts words one by one using learned context. Now, why is this faster? It's because of LSTM. So, word 1, word 2, word 3, word 4, so on, right? Till word n. This is in sequential order. What transformer does is it processes all the words simultaneously. So, think of it as parallel processing or like GPU scaling or like massive scaling or anything which stays in your mind. Now, third is why transformer changed AI or how it changed AI. So before 2017, building NLP systems required task specific models, huge engineering effort, months of fine tuning, etc. After transformers, one architecture works everywhere. So for example, let's take ChatGPT. uh, if we type explain black holes simply, what transformer does is it understands the context, predicts next word repeatedly, and then generates a human like explanation. It basically is advanced next word prediction system. Now if you take the second example of BERT, for example, the query is bank near river. Now what old searches would do is it will show you financial banks, right? Like SBI or RBI or something. But what transformer does is it understands the context. So it means a river bank, right? It understands that part. Now if you take DAL-E, which is like a text to image generation tool, although I've never used it, but I'm sure it'd be great. So if we give an input as astronaut is riding horse in space, right? So what transformer does is transformer connects language concepts to visual patterns which is learned during the training, and then it generates output image where, for example, I'm riding a unicorn in the space, right? The fourth example is like GitHub Copilot, right? So when you type, for example, something like define add of a comma b, right? The model predicts the likely continuation of return a plus b. So it learned from like patterns from millions of repositories, right? Similarly, we have AlphaFold. I think it is used to predict the amino acid sequences. It's a 3D structure prediction tool. Then you have speech models, etc., etc., right? Now let's go with how transformers were born and what was its origin story. So this basically happened in three stages. Stage 1 was sequence to sequence with LSTM. This happened in 2014. So the process was read the entire sentence, compress meaning into one vector, and then decode the translation. But what was the problem with this? The problem was one vector was equals to information bottleneck, right? So it worked for short sentences like I'm happy or I'm sad or something like that. But long sentences failed because the details were getting lost. It was like summarizing the entire book into one word. In stage 2, they built the attention mechanism in 2015. So instead of one vector, it allowed decoder to look back at all the words. So while translating, for example, translating Paris, it focuses on France. While translating spring, it focuses on spring. Because of the attention mechanism, the accuracy improved massively. Then in stage 3, Transformers, which was in like 2017, right? I'm sure you guys would have heard of this. Attention is all you need. It was everywhere, right? So researcher asked a very basic question. If attention works so well, why keep LSTMs at all, right? So they removed recurrence entirely. Now, what was the result? Result was fully parallel training, faster learning, better performance. This was the paper name, by the way. Attention is all you need, and honestly, that is all we need. Then came self-attention. Self-attention lets words interact. Now, what does this mean? Each word creates three vector: query, key, and value. Query is like what I'm looking for. Key is what I contain, and value is the actual information. So the similarity is computed as attention is equals to similarity of query comma key. So high similarity equals to stronger influence. So meaning becomes context aware. For example, Apple released an iPhone and I ate an apple. Same word but different meaning because of the context. Now let's talk about the advantages of transformer. So it allows parallel training. All tokens are processed simultaneously. So this gives faster training and huge models are possible. Second is transfer learning. Transfer learning is basically train once on massive data and then fine tune it. For example, pre-trained BERT, right? Used for like spam detection, sentiment analysis, customer support, classification, etc. All these needs very little data. Third is multi-model capability. Multi-model is like if you have done research work, we try to build two uni-model. Like for example, if we have to find something like if a plant is healthy or not, or second part where we have to predict like disease or something. So we take a text value and then image value or like text, audio, video, whatever we have. We try to build two separate uni model and then we build a multi-model. It's generally assumed or given that a multi-model performs better than a uni model because from like images and everything you can do feature selection and all that, right? Feature extraction, and then you combine that value with like the text value and then you make the final prediction. So the final prediction is more refined, right? So it gave us multi-model capability. Then there was like flexible design. So we had variants like for example, BERT was encoder only, GPT type was like decoder only. Then came T5, which is encoder plus decoder. They have like a strong ecosystem. They have libraries like Hugging Face, etc., etc. Now let's talk about the challenges, right? So transformers are powerful but not perfect. It has high computation cost. Training GPU levels, or at least model level GPUs, they know GPT, they require like thousands of GPUs, weeks of training, or like months of training, to be honest, and then million if not billions of dollar. These are like data hungry, right? Without pre-training, model just overfits easily, so it needs massive data sets. Third one is like energy consumption. So training these large model consumes huge electricity, and that is like a big environmental concern, right? I've seen plenty of you guys, not you guys exactly, but I've seen these memes on Instagram where like Trump is walking out of a college, or like Ayatollah Khomeini is walking out of the college, and Trump is waiting on his Lamborghini, or if I don't know if I'm getting the car right. I think it's a Fast and Furious scene. I don't remember the movie, so sorry for that. Then there is limited interpretability. Then there are like black box problems. So we know output, but we don't fully know reasoning steps internally. It is critical basically in field of medical or law. Then we have bias. Model learns from the internet data. If data contains bias, model reproduces those bias. Now let's talk about future of transformers, right? So researchers are improving. There are smaller efficient models. For example, there are techniques like pruning, quantization, distillation. The goal is to run AI directly on phones, right? Then we have deep multimodal AI. For example, one model for handling text, image, video, speech, everything seamlessly, right? And then instead of building a general AI, we try to build a medical AI which focuses on medical part, a legal AI which focuses on legal part, and a scientific AI which focuses on the scientific part. So we have like more accurate specialized systems, right? So to understand everything at once, or to summarize this, think of transformer as a system where every word talks to every other word at the same time to understand the meaning before generating the output. Okay, thank you everyone.